Okay, so today we're going to be starting the unit on geologic history. Geologic history. All right, so in geologic history, we look back and we're trying to figure out how old things are. All right, now there's different ways you can describe how old something is. You can talk about its relative date or its absolute date. All right. So first off, with relative dating, what relative dating is when you put things in their sequence of events, or you put things in order of when they happen. So if I said A is older than B, I know that A happened first, then B happened. I'm not saying specifically how old A is or how old B is, just A happened first, then B happened second. All right. A could be 1,000,000 years old and B 500,000 years old. Or A could be 2 days ago and B 1 day ago, or A could be 1,000,000 years ago and B could have been yesterday. Just A happened first and then sometimes later B happened. Right. Absolute dating is when you put an actual number value on how old they are. So instead of saying A is older than B, I'd say like A is 10 years old, B is 5 years old. All right. Now, you might wonder, why would you bother worrying about relative dating if you could just find the absolute dates of things? Well, as it turns out, finding the absolute dates of things is pretty tough. Relative dating, if you just follow some rules, which we're going to be looking into shortly, is actually fairly easy to do. Most of the rocks you find on the Earth's surface are made out of sedimentary rocks, and they're deposited a certain way. It's easier to figure out what happened first, what happened second, what happened third. With absolute dating, how you go about doing that is through radioactive dating. The thing is, you can't find the age of sedimentary rocks doing radioactive dating very well. Why that is, we'll talk about later. Metamorphic rocks, it doesn't work so for metamorphic rocks. It really only works well for igneous rocks. So you're kind of handcuffing yourself right off the bat. So how you actually go about doing absolute dating, we're going to look at it another day. But for right now, we're just going to focus on how you can figure out the orders of things, or how we can figure out the sequence of events. All right, the relative dating. All right, so sequence of events or relative dating. All right, so there's rules that you have to follow. Once you know these rules, it's actually pretty easy, I think. A lot of relative dating problems, I kind of look at them as like being puzzles. All right, first rule is principle of superposition. Under normal circumstances with sedimentary rocks, the oldest layers on the bottom and the youngest layers on top. All right, so if you imagine, if these are rock layers, this one had to form first, then this one got deposited on top of that one, so that would be older than that one. Another layer gets deposited on top of it, so that'd be the oldest, medium, youngest, right? And that's going to hold true 99% of the time. Oldest on the bottom, youngest on top. All right. Now, just like with newspapers, all right? If I have today's newspaper, I get done reading it, I stick it on the back porch. Next day I get the newspaper, get done reading it, stick it on the back porch. Next day I get the newspaper, get done reading it, stick it on the back porch. So after a while you have a stack of newspapers, oldest newspaper on the bottom, most current newspaper on top, same idea. All right, now some exceptions to this rule, all right? One is what's called an overturn fold, all right? Now with a regular fold like this, it'd still work out that oldest, medium, youngest. What an overturn fold is when the rock layers do that, and it does happen sometimes. Now, when I have an overturn fold, what I have is oldest, medium, youngest, but then in this section right here, I have youngest, medium, oldest. So for this localized section right here, I actually have older rock sitting on top of younger rock. Right? So that is an exception. This little piece right here is an exception to the principle of superposition, because right here I actually have older rock sitting on top of younger rock. All right? But again, it's just that little area right there. Another exception to that rule is reverse faults, all right? Now remember, you have different types of faults. A normal fault is when they pull apart like this. Transverse faults when they go this way, or transform faults is when they go this way. Reverse faults is when they go that way. All right, now normally, oldest, medium, youngest, but if I have a reverse fault that goes like that, all right, now I have older rock sitting on top of younger rock, all right? So that would be an exception to the rule right there, where I have the older rock sitting on top of the younger rock. But again, it's only going to be for that little localized area right there. So 99% of the time, older rocks on the bottom, younger rocks on top. All right. So right here, if I wanted to figure out the relative ages of these rock layers right here, step 1 would be rock layer A formed. Step 2 would be rock layer B formed. Step 3 would be rock layer C formed, because C's on top, so it's the youngest. Okay. Or if I was doing this one right here, this one's got a little added wrinkle to it. When you see squiggly line like that between layers, that's something called an unconformity. And what that means is erosion took place, right? So this would be D formed first, E formed second. Now there could have been stuff on top of E, but what happened is it eroded away. So there's eroded. Then after the erosion, F formed, all right? So D, E, there was some erosion took place, eliminated some rock layers. Now it might have been just like a few inches of rock, or it could have been, 20 feet of rock. Because all that information's missing now. I just know that there was some erosion took place, and then F formed sometime later because it's on top of the erosion. All right. All right. Next, igneous intrusions and extrusions. Intrusions. Remember, intrusion is when magma comes up from deep down in the earth. It goes through the rock layers. If it stops before it reaches the surface, it's called an intrusion. If the magma comes up to this and actually works its way to the surface and kind of flows across the top, that's an extrusion. Right. So intrusions, younger than the rocks they cut through. Extrusions, younger than the rocks beneath them. All right, so this guy right here, all right, for X, Y, and Z, all right, so the first thing to happen for these guys would be the bottom layer formed, so Z formed first, then X formed, then Y formed, all right? Then after all three of those layers formed, then I had this igneous intrusion came up. So I'm just gonna write NIT for intrusion. All right? For this guy here, all right, G formed first, H formed second, right? And then this magma came up, reached all the way to the surface, and then started flowing across the surface. We call that an extrusion. So put EXT for extrusion. All right. Now, and add a little wrinkle to this. Contact metamorphism. Rock layers must first be present for metamorphism to happen. So like in this guy right here, because remember how contact metamorphism happens is hot magma or hot lava touches rock that's already there, and the heat from that magma changes the rock that's already there. Now, a lot of times on diagrams, contact metamorphism is represented by that kind of like hairy symbol right there. Now, for this diagram here, I know that X, Y, and Z all had to exist before this guy here came in because there's contact metamorphism all the way around. That means these rock layers are here when this magma came up, because when this magma came up, the heat from the magma caused that contact metamorphism, right? Now this guy right here, if I notice, it has the contact metamorphism, so G and H were there first, and then I could tell that G and H were there first because there's contact metamorphism there. But if you notice on top, there is no contact metamorphism on top, because with an extrusion, what's on top here is air, and there's no such thing as contact metamorphic air. All right, so there's no, so with extrusions, there's no contact metamorphism on top. All right, so GH, and then the extrusion happened. All right, this guy right here, all right, this guy right here, and now, actually, yeah, that's good. All right, now at first glance, this might look a lot like that one right there, but there's one really important difference between them. And the really important difference is this one doesn't have any contact metamorphism on top, where this one did. All right. The significance of that is that because there's contact metamorphism there, that means this rock layer was there first, then this came up and touched it. Since there's no contact metamorphism there, that means that this layer was not there when this came up. So the sequence of events for this guy is X happened first, all right? So X happened, then this guy came up. These rocks up here didn't exist yet, so this came up and reached the surface. So this would be an extrusion, all right? This would be an extrusion. There's contact metamorphism there between the X, because X was there first. Y wasn't there yet, so there's no contact metamorphism. So after the extrusion came, cooled and hardened, then Y formed, then Z formed, right? So this is X extrusion, cooled and hardened, Y formed, then Z formed. All right. Now this guy right here, looking at this guy here, what I know is you got the sequence, you got the principal superposition, oldest on the bottom, youngest on top, and we know that rocks have to exist for there to be contact metamorphism. But for this guy right here, the added twist to this one is, so I go M, N, I know M and N were there first. All right. Now, sometimes there's more than one correct possible explanation, because I know M and N happen, and I know Q happens after N, because Q's on top of N, and I know this intrusion happened after N, because there's contact metamorphism between N and the intrusion. But what I don't know is what the age is relative to each other between the intrusion and Q. So this has two possible answers. This could be M happened, N happened, then Q happened, then there was an intrusion. That could be right, that form, that form, that form, then this came up but only got that far. Or another possible explanation to this would be M happened, N happened, then there was an intrusion, and then after the intrusion happened, I know the intrusion happened after M and N because there's contact metamorphism there. Then after the intrusion happened, then Q happened sometime later, all right? Now in reality, only one thing could have happened, but I can't tell which one of these two scenarios it was just by looking at the diagram. So if I was asked to do the sequence of events for that diagram, either one of these would be acceptable, because either one of these is what you could get by looking at that. All right. Next, folds, faults, and joints, which is another word for a crack, are younger than the rocks they are in. All right. So for rocks to look like this, they have to exist before they can fold. So to get something that looks like that, what would have to happen is that layer forms first, that layer forms second, that layer forms third, then they fold it. So a fold has to happen after the rocks that are in the fold formed, all right? Or the same thing applies to a fault, all right? Rocks have to exist before they can be faulted. So if I had a fault that looked like that, all right, the sequence of events would be this formed first, this formed second, this formed third, then they faulted. So that to get that, all right, it would have been that formed first, that formed second, that formed third, and then they faulted. So a fault is younger than any rock layer it cuts through. Right? So if I have a feature that looks like that, all right, so that's a fold, the sequence of events would be R formed first, S formed second, then they folded. Right? These rock layers had to be there first before they could fold. For this guy right here, excuse me, C had to form first, all right? D had to form second, and since that fault cuts through both C and D, that means the fault had to happen after both of those. So it would be C formed first, D formed second, then they faulted. All right? And as far as joints or cracks, all right, if I have a rock and I have a crack in it like that, well, the rock had to exist before the crack did, so the rock formed first, and then it had a joint or a crack in it. Now, in reality, when you do these, it's usually a combination of these factors come together, and you have to kind of sort through these various things. So like, let's say this guy right here, there's a few things going on with this guy right here. I have the rock layers formed, I have a fold, and I have a fault. So if I'm going to do a sequence of events for those things, well, first off, the rock layers have to exist before they can either be folded or faulted. So the first thing that would form would be B. The second thing that was formed would be A. All right, so the rock layers have to exist. Now I got to figure out what's going to happen, the fold or the fault. All right. Well, if I look, the fault cuts through the fold. Right? Because the fault cuts through the fold, that means the fold had to be the next thing that happened. So they folded, and then they faulted. So that was B, then A. They folded, and then they faulted. All right. This guy right here. All right, got a few things going on there. So I have the rock layers again. I got a fault, and I have an igneous something or other. All right. So again, the rock layers have to exist first for stuff to happen to them. So the first thing that happened there was K. The second thing that happened there was L. All right, now I got a fold and, or excuse me, I have a fault and an intrusion. Now I know it's an intrusion and not an extrusion because there's contact metamorphism on top. Extrusions do not have contact metamorphism on top, so I know that's an intrusion. And what I do know is that the intrusion has to be younger than the fault, and the reason being is if the intrusion happened before the fault would have cut that intrusion like it has the other layers. So this is K formed, L formed, then they faulted, and then there was the intrusion was the last thing that happened there. All right. So that would be the sequence of events for that guy right there. All right. Now, the last thing we'll mention here are some internal characteristics. What I mean by that is most of the things we've looked at so far are more of a grand scale. You can also have a sequence of events for small hand-sized specimens as well. Fragments in a sedimentary rock are older than the rock. All right, so let's say I have a piece of sedimentary rock, a piece of conglomerate. Conglomerate's made out of pebbles cemented together. So here's my 4 pebbles cemented together to make a piece of conglomerate. And let's say I take pieces of those pebbles and I find the exact ages of them. So this pebble right here is 100,000 years old. This pebble right there is 800,000 years old. That pebble right there is 20 million years old. That pebble right there is 4 million years old. All right. Now, all those rocks had to exist for them to be cemented together. All right. Now, the youngest particle there is 100,000 years old. So if I had to make estimate of what the age of the rock as a whole was, it would have to be some date that is younger than 100,000 years old. Because again, the rocks have to exist to be cemented together. All right, so just like with a brick house, if a brick house was built 100 years ago, you know the bricks have to be at least like 101 years old because the bricks had to exist before the brick house could be built. All right, the house can't be 100 years old and the bricks be 95 years old because you need the bricks to make the house. Same idea here. All the particles had to exist for them to be cemented together. So the age of the rock as a whole has to be younger than the younger particles there. All right. Lastly, cracks and mineral veins are younger than the rocks they're in. All right. So I already said before that a rock has to exist before it can be cracked. All right. So like with that rock right there, it has a crack in it. The rock happened first, formed first, and then the rock cracked. All right. Now what sometimes happens is that crack will fill in with hard water. That's water with minerals dissolved in it. And what can happen is the minerals come out of the water and it fills in that crack with another type of mineral. All right, so that's a way that you can get a mineral vein. So if I saw a rock that looked like that, I know that this part of the rock had to exist first, then the rock had a crack in it, then the crack filled in. So that'd be the sequence of events for that rock. All right, now, on your paper, you got a couple sequence of events problems. So you got that one right there, and there's one on the back. So let's look at those two problems. All right, so let's say I want to do the sequence of events for this right here. All right. Now I'm going from oldest, number one's the oldest, and I'm working my way up to youngest. All right, so first off, oldest rock layer. Now you might be tempted to say A, because A is the farthest down, but A is part of this intrusion that cuts through other rock layers. So A to happen sometime later. So the farthest one down would be B. So B is the oldest layer. Next one above B is that layer right there, which is layer C. Right. Next one would be that layer right there, which is D. Next layer is that guy right there, which is E. All right, so I have the rock layers formed. All right. Now, looking on here, what I noticed, the one feature that cuts through everything else in that diagram, if I notice this fault here cuts through everything else in that diagram. So that would make the fault is going to be the last thing that happened. All right, so the fault I said is G, so that's the youngest thing, because that cuts through everything else in that diagram. So that's going to be the seventh step. All right. So then that leaves me with the fold and this intrusion, and sometimes it's hard to tell. In this case, I would probably say the fold happened first and then the intrusion. But you could probably make an argument to have these two flipped around. All right, so I'd probably say this order right here. So this layer, this layer, this layer, this layer, then they folded, then there was an intrusion. I know the intrusion happened after all those layers because there's contact metamorphism there. And then they faulted. All right. I would probably say this order here, but you can make an argument for having those two flips. All right, so that would be a sequence of events for that guy right there. All right. One more example. All right, so for this guy right here, what you have to imagine is all these layers here flattening out. So if I take all these layers here and flatten them out, the farthest rock layer down would be this guy right here, which is layer D. All right. Then the next layer would be this guy right here, which is layer E. All right. Then the next layer would be this layer right there, which is Q. The next layer would be this layer right there, which is layer T. All right. Then what happened is all those layers, D through T formed, and then what happened is those layers bent like that, so they folded. All right. So the layers bent like that, but then what happened is the top of that eroded away, the top of the fold eroded away. So we call that, when rock layers are eroded away and you're missing stuff, erosion or an unconformity. So we call that Z. All right. So the rock layers eroded away at Z. All right. Oh, and by the way, a fold, I'm supposed to write the letter A for fold. All right. So the fold was A. So then, after the top of those layers eroded away, then that layer right there formed, which is layer Y. Then after layer Y formed, then layer X formed. Right? So that is a sequence of events for this diagram right there. D, E, Q, T formed. They folded, eroded away, then Y and X formed. All right? So that's how you do sequence of events problems. And I always like these things because I think they're kind of like puzzles, but hope you enjoy.